Bismillahirrahmanirrahim. Hello everyone and Assalamualaikum. First thing first, let me start by giving some background information. First, my name is Muhammad Ahmad Mezanal and here's my members, Muhammad Daniel Mukris, Muhammad Nur Hazi Azhad, Nur Azman and Ahmad Daniel bin Abdul Manaf. So next, for the starting, let me introduce what is transfer function. Basically, transfer function is a fundamental concept that plays a crucial role in the analysis and design of linear time invariant, or we call it LTI system. Transfer function of a system is defined as the ratio of the Laplace transform of the output of the system to the Laplace transform to the input of the system, assuming all initial conditions are zero. So for the next part, I will explain what is dot plot. Basically, dot plot is divided by 7 factors and each factor is divided by 2, gain and phase. So, what is dot plot? Dot plot is a graph of the frequency response of a system. It is usually a combination of both magnitude plot and expressing the magnitude to the frequency response. And a dot phase plot is expressing the phase shift. So, what is phase at the dot plot? So, phase is the angle of the complex number that is representing the transfer function of each frequency. It indicates how the output signal is shifted in the time relative to the input signal.
So, Assalamualaikum. My name is Muhammad Daniel Mukris bin Zulkifli. My matrix number is B1123100509. So for the next slide, we go direct to the required question that we need to answer, which is the transfer function for part A. So before we go to the calculation, actually I represent my teammate to apologize to Madam Shuhada. Actually we don't have a proper device to actually explain one by one for the equation, but we try our best to what we call presenting how to calculate, how to solve the transfer function for part A. Just follow the step, inshallah we can do. So let's go. We go to the question. A is stated that the transfer function is 200 JW over JW plus 2 multiplied by JW plus 10. So for transfer function, actually when we want to convert it to ball plot, we need to simplify it first by referring the table of dot plot that at the previous slide. So what we do on the slide, we can see actually I just simplify the denominator for the equation and change it into the simple pole, which is JW plus 2. I transfer it, I convert it into 2 multiply 1 plus JW over 2, and then for JW over 10 I convert it into 10 multiply 1 plus JW over 10. Make sure when you do this kind of thing, you must to expand it back and then make sure you got the same answer. So after you got the equation, just masukkan balik, and then as we can see on the slide, it say that 200 JW over 2 plus 2 multiply 1 plus JW over 2 multiply 10 multiply 1 plus JW over 10. So as we can see, we can multiply 2 with 10, which is we can see 200 over 20, and then we can cancel out. 200 become 20 and 20 become 1. So the simplest equation that we can get actually 20 JW over 1 plus JW over 2 multiply 1 plus JW over 10. So from that is simplest transfer function that we can use to make the ball plot for magnitude and phase. So before we do the ball plot, we must to divide all the equation by referring the table of ball plot. So we can see 20 as a gain, JW as a 0 at origin, simple pole which is 1 over 1 plus JW over 2, and then we have another simple pole which is 1 over 1 plus JW over 10. So from that we know for this equation we have 4 main graph. So from that we can do the ball plot. So at the previous slide, you see that the ball plot have two functions, which is we have the magnitude and phase. So actually transfer function can do both ways. If you have the transfer function, the simplest transfer function, you can ball plot it into two types, which is the magnitude and phase. So for the next slide, we can go make the ball plot for the magnitude. So make sure when you do the ball plot, you must to have the table of ball plot to make sure you just make the correct one. So as you can see, I will try my best to explain one by one. Just follow me. So first one, we go to the red line. You can see on the slide, the red line is stated on the gain. Is a gain. So by referring the table of ball plot, is stated that the gain of the equation we start on the 20. That's why the red one is start from 20, not from 0. Okay, next we go to the green line, which is the second one, which is 0 at origin. So when we referring table of ball plot, is say that the JW must starting from negative 20, and then it will intercept at 1 at the x-axis, as you can see on the graph. It intercept at negative 20 at the y-axis, and then when it reach x-axis, it will intercept on it. So we can see it like a upward slope for the JW, which is 0 at origin. So we done for the second graph. So we go next for the third graph, which is the simple pole. So for the simple pole, actually you must to be careful because it have its own x-axis. How to know actually what is x-axis? So actually if you want to know the x-axis, you must to look out the equation, which is we can see the JW over 2. So actually the denominator of JW actually the point of x-axis that will be intercept. So at the graph we can see the yellow color. Okay, for the simple pole, actually it will start from 0. So from 0 it will be straight line until it goes to the 2 at the x-axis, and then it will slope down. Why is slope down? By referring the table of ball plot. Just a simple thing. And then for the graph 4, just repeat the same thing as you do at the graph 3, but the x-axis will be 10 because what? The JW for the denominator of JW is 10. So from 0, just straight up, and then when it reach at the 10 at the x-axis, and then it will be sloped down because what? Because it is simple 0. Just referring the table of ball plot, and then you can do it. So when you have 4 graphs, what we need to do? You must combine all the graphs to make a result. So how to make a result? You need to do the region. You need to divide all the region. How to divide all the region? So the way you want to divide the region is you need to find all the point that the slope goes down, goes up, that the slope intercept at the x-axis. So actually you can see that the first slope is at the 1, 2, 10 and 100 at the x-axis. So first, when you want to start the result, you need to find the starting point. Okay, how to find the starting point? So the way you want to find the starting point, actually you need to calculate all the 4 graphs by seeing the x-axis, which means you can see the first graph is starting on 20. For the second graph is starting at the negative 20. For the third and fourth graph is starting on the 0. So you just sum all of the x-axis. As you can see below of the slide, the starting point actually is 20 plus 0 plus minus 20, and then you get 0. So 0, actually the 0 is actually the starting point. It's not the line, it's a starting point where you want to starting the result graph. So you have 0. So between 0, the region between 0 and 1, you can see the graph is upward. You can see the graph is upward. So actually to combine the graph, you need to see actually the graph goes up or goes down. So when it goes up, it will be 20. When it goes down, it will be negative 20. So at the first region, which is 0 until 1, you can see actually the graph that goes up only 1, which is the JW, 0 at origin. So that's why the 0 will goes up until 20. But before it reaches 20, it intercept at the x-axis 1. So after that, you need to see back the graph slope. So at the region between 1 until 2, they have no other graph that slope down. So you need to just continue until the region 2. That's why if you can see the result graph between the region 0 until 2 is starting increasing until 20, because it's only upward graph slope that's stated on it. But the region between 2 and 10, the graph is just consistent. Why? Because if you can see between region 2 and 10, they have two graphs, which is the upward and downward. So the upward, which is the JW, and then the downward is the third graph, which is 1 over 1 plus JW over 2. Right? So 20, you must remember that the graph that goes up is 20, the graph goes down is negative 20. So 20 plus minus 20, it will be 0. That's why the region between 2 and 10 is 0, means consistent. They have no change between that region. But the region between 10 and 100, they have different, which mean you can see they have 3, which is the one graph goes up, which is the 0 at origin, but 2 graph goes down, which is a simple, both of simple 0 graph, which means 20 plus minus 20 plus minus 20. So it means minus 20. So you must to write up you must to draw the graph from the region 0 to the 20, and then just goes down directly. Because what? Because they have no change after the region 100. And then that's how you get the result of the graph. Just a simple how to make the magnitude bold plot. So next we go to the next slide, the way how to make the phase of the bold plot. So the difference, actually that's the same thing. Both magnitude and phase, just the same thing, just the same way, the step that you need to do, but it have the own requirement. Magnitude have its own requirement, and then the phase have its own requirement. So that's the same thing we apply, which is we also using the same calculation, which is the 20 JW over 1 plus JW over 2 multiply 1 plus JW over 10, and then we make it into the phase bold plot. So first, what we need to do, we need to find the gain. So by referring the table of bold plot, you see that the gain will start at the 0 degree. So for phase, the difference actually, the y-axis will be the degree, and then the x-axis will be the Weber. So for more easier, I will explain by using x-axis and y-axis. So sorry. So for the 20 gain, so we'll draw the line, the red line, which is 20 gain at the 0, and then it's done for the gain. Simple, right? So next we go to the 0 at origin. So by referring the table of bold plot, is stated that when the phase at 0 at origin, the graph will be 20n. So 20n, n is what? N actually the power of JW. If we see the graph, if we see the calculation, JW doesn't have power, means JW power of 1. So 90 multiplied by 1 is also 90. So we make a graph, the green one, stated JW at the 90. So we done for two graph, and then we next do for the simple pole graph, but for the phase. But you must to remember, when we dealing with the phase, we must to be careful with the x-axis, which is the Weber. Because what? When we go to simple pole, the x-axis will be changed, which means it have its own calculation. So if we can see on the previous slide, the phase x-axis point, which is the calculation is p over 10, p, and then 10 over p. So what is p? P is also same the denominator of jw, which is we have 2 and 10. So just multiply like regular, which is for the graph 3, we have the x-axis, which is 0.2, because 2 over 10, we have 2, and then 10 multiplied by 2, we get 20. So for the simple pole for the graph 4, 10 over 10, we get 1, and then 10, and then the last one is 10 over 10, we get the 100. So just simple, just plotting the third graph by using the x-axis, which is 0.2, 2 and 10, okay, 2 and 20, my bad. So by the first, we need to referring by the ball plot. So the table of ball plot stated that the simple pole graph will starting at the 0, and then it will be sloped down when it reach p over 10. So for graph 3, p over 10 is 0.2. So for we referring on the purple, I think the purple line is the third graph. So it will start on the 0, and then when it reach at the x-axis 0.2, it will be sloped down until the third axis, which is 10 multiplied by 20, 10 multiplied by 2, which is 20. So from 0.1, it will be sloped down until x equal to 20, and then y equal to negative 90. So after that point, the graph will be consistent, which is will be 0. So next you need to do the same thing for the fourth graph, which is the yellow one. It's starting on the 0, and then it will be starting slope down at a 1 until 100, because what? 10 multiplied by 10, you get 100. So it will be sloped down from 1 until 100. After it reach x 100, y negative 90, it will be consistent. So you have all the four graphs. You need to do the same thing like a magnitude, which means we need to combine all the graph to become a result. So how? So the first thing, you need to find the starting point. So how to find the starting point? You need to sum up all the x-axis, all the y-axis. All the y-axis, which is for the graph 1 is 90, for the green line is 90, for the red line is 0, and then for the third and fourth graph also a 0. So as we can see the below of the slide, we can see find the starting point, which is 90 plus 0 and then plus 0, you get 90. So the starting point will be at the 90. So you can see the starting point at the 90, and then you just draw a line. The result will be the light blue. So you draw the line until it reach the region between 0.2 and 1. So when you at the region, you must to look at the graph. Either they have a graph slope down or slope up. Okay, the region at 0 and the region between 0.2 and 1, you can see they have only one graph is slope down. So you just draw a slope down graph until negative 90. But before it reaches negative 90, it find another region, which is between 1 and 10, between 1 and 20. So between 1 and 20, we can see they have two slope down graph, which is the yellow and the purple one. Which is what we need to do. We need to sum up, which is negative 90 plus negative 90. We get a negative 80. So you need to tone down the graph. That's why you can see the difference between the line at the region between cursor 0.2 and 1 are different. The slope down between 1 until 20, because what? The angle is different. The region the graph at the region between 0.2 and 1 is 90, but the region between 1 until 20, the angle is become more, which is negative 120. That's why the graph are being toned down more rather than the graph at 0.2 and 1. So when the graph are reached at the next region, which is 20, you must to see the next region, which is 20 and 100. So when you at the 20 and 100 region, you must to see the graph. As we can see, only one graph is sloped down, which is the yellow one. So negative 90. So from negative 180, you need to just make it up the angle into negative 90. So just straight up until the region to negative 90. So after the region 100, you can see the result graph just a straight line. Why? Because all the graph from green, red, yellow and purple just a straight line. That's why the result graph will be the straight line. And then that's how you want to make the result for paste bone plot. I think that's all from me. Thank you so much. And then we will go to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I am Nur Hazil bin Azman as your third presenter. Today I'm going to discuss about another subtopic, which is board plot E. Okay, first of all, we are going to interpret the first part of the graph, which is from value 0 to 5 on the x-axis. As we can see on the y-axis, we are given the value of 20 decibels of gain. Which is in the formula or in the board plot, we can refer to the factor, which is the factor is called SK, with the formula 20 log 10k equal to 20 dB and k equal to 10. Okay, for the second region, we are giving a value as x-axis, which is 5 to 10 Weber radian per second, and at this region we can see the graph are slightly increased about 20 decibels. And if we refer to the board plot, this is what we call simple zero factor, which simple zero factor with slope at Weber equal to 5 radian per second, and the formula is 1 plus JW over 5. Next, for the third region of the graph, we are given a value from 10 to 100 Weber radian per second. Okay, at this point we can see the graph in the horizontal or straight line. This is because before this we are going to add 20 decibel because simple zero board plot, and for this third region we are going to minus 20 decibel for simple pole. So the graph become zero value, and formula for simple pole is 1 over 1 plus JW over 10. Okay, for the last region of the graph, we are given a value from 100 to 1000 Weber radian per second, and this graph are drastically decreased to the zero, which is, if we refer to the board plot summary, this vector what we call is quadratic pole with the formula 1 over 1 plus JW over 10 square. Okay, next we are moving to the next part of the board plot, which is the final product. As you can see in this slide, we already write the final product, which is HW equal to 10 in bracket 1 plus JW over 5 over in bracket 1 plus JW over 10 in bracket 1 plus JW over 10 times by 2. Last but not least, for this calculation, we are going to multiply and divide all the values that we are take out from the JW. Okay, as you can see in this calculator, we are just insert the value from 10 times 1 over 5 divided by 1 over 10 times 1 over 100. So we got all the final value is 2000 2000 JW plus 5 over JW plus 10 times JW squared plus 100.
Assalamualaikum, my name is Ahmad Daniel. I'm the last presenter of this group. I'm going to explain and discuss about transfer function. The concept of transfer function central to the analysis and design of linear time event LTI system, offering powerful tool for understanding the behavior for characteristic of this system. A transfer function denoted as H S is defined as the ratio of the Laplace transform of the output Ys to this Laplace transform of the input Xs when all initial conditions are assumed to be zero. And last but not least, I'm going to conclude of this topic. The transfer function is versatile and fundamental tool in the analysis and design of LTI system. It provides a clear and efficient means of characterizing system dynamic, predicting system behavior, and design appropriate control strategies. Through the use of transfer function, engineers and scientists can systematically approach complex problems in variety of fields, include electrical, mechanical, and control engineering. That's all from us, and thank you for lending us your ear.